Hi, my name is CHARLESTER UMPI LOIUS and I'm going to explain a little bit of DC booster. So what is a DC booster exactly? It is a simple converter which is used to convert DC voltage from low level to higher level of voltage. Boost converter is also known as DC to DC converter. So based on the features shown in the slide, it is show the connection of the circuit, which inductor parallel to the switching, and then diode, which is in series with the capacitor. Actually, there will be another parallel branches over here, which shows the load of the circuit.
Assalamualaikum, my name is SYAHMINA binti Muhammad SHAFIK. So I'm going to start with the difference circuit between DC to DC converter. So in DC to DC converter, they have non-isolated and also isolated DC converter. So I'm going to start with the difference between non-isolated DC converter. So each of the converter have a different type of circuit. So they have buck converter circuit, boost converter circuit, buck boost converter circuit, chuck converter circuit. All of them have a different position in all of the component, but the component are the same. So the component is DC voltage source, resistor as a load, capacitor, inductor, a diode, and also the converter component. So all of them is the same. What is the different is the position of it, and it will create a different analysis also. So to know the difference, you can be easily analyzed by understanding the operation of the circuit.
So we're going to discuss on operation of the DC booster. So when the switch is turned on, current can flow from the DC power supply through the inductor over here, and then through the switches and back to the DC supply. As the switch is turned on, it's flow through the inductor, right? And then this inductor will then store energy and create a magnetic field. Meanwhile, it is current flow through from the DC to the inductor and back to the power supply. The polarity of the inductor is positive on the left side and negative on the right side, as you can see here. So when the switch is off, current can no longer flow through the switch. It flows through the diode and the capacitor and the load, and back to the DC voltage supply again. During the switch is turned off, the polarity of the inductor is negative on left side and positive on the right side. During the switch is turned off, the inductor which was created initially, then returning the energy to circuit. The magnetic field is collapsed and create a voltage spike which is stored in the capacitor. Alright, so I'm going to discuss a little bit on elaboration of the turn off state. Every time the current shoots through this part of the circuit, through the rest of the circuit, the collapsing magnetic field create a high voltage spike and then causes the current to flow through the diode and then through the capacitor. And then the voltage will store in the capacitor over here. Because there is diode over here, this stops current from flowing backward, which means only allow the current to flow back into the DC voltage supply again over here. From the capacitor to the switch, once it turns on and back to the power supply, every time we get a voltage spike from this inductor, this adds to the voltage of the capacitor and therefore step up the voltage of the capacitor over here. Yes, as we can see, initially we start with 9 voltage DC power supply, but then it keeps on stepping up the voltage of the capacitor until the reading of my simulation reaches 24.8 volt.
For simulation circuit, this is the circuit that we construct. For duty cycle generator, we use MOSFET as it is a suitable component to use. The main advantage of using the power MOSFET as voltage control resistor is that the control of the converter is simplified. It also has a lower power consumption than BJT. So it is one of the biggest advantage of using a MOSFET. And biasing a MOSFET is simple. So that is why MOSFET is easier component to convert DC to DC voltage. Okay, so here's are the parameters that we put in the circuit. So the frequency that we chose is 100 kHz and the duty cycle 0.4. Okay, so here's the duty cycle waveform. So for the simulation value of duty cycle, we got 0.4348, while the calculated value of duty cycle is 0.4. So the calculated and the simulation value is the same. There is no error in the calculation. So next is the output voltage waveform. So this is the waveform that we got. So for the simulation voltage output, we got 82.38 volt, while the calculated voltage output is 83.33 volt. So there is a small difference between the simulated and also the calculated value. Okay, for the simulation voltage output ripple, we got 0.07 volt, but the calculated one is 0.07 volt. So the value is the same as it shows that there is no error between the simulation and also the calculated value. This is the current waveform. So for the simulation, minimum inductor current, we got 2.563 ampere, while the maximum inductor current is 3.056 ampere. So the calculated value, minimum inductor current is 2.53 ampere, while the maximum inductor current is 3.03 ampere. So the value for calculated and also the simulation is just a small differences, but I think that the value for simulation and also the calculation is acceptable as it is only a small difference. So IZZUDIN will tell more about the calculation on how to find the value.
Assalamualaikum, my name is IZZUDIN bin HAMIM. So let's move on to the formula and calculation part. Firstly, we have to find the voltage output. The formula for voltage output is V input over 1 minus duty cycle, as we can see here. So the value is VO equals to 83.33 volt. After that, we have to find the voltage ripple. The formula for voltage ripple is V output multiplied by duty cycle over RCF. RCF means resistor multiplied by capacitor and frequency. So the value is 0.07. This value is same with the simulation value, as we can refer to the previous slide. After that, we have to find the current at inductor. In inductor, we have two values, which is maximum value and minimum value. In order to find these two values, we have to find inductor first. The formula for inductor is V input over 1 minus duty cycle to the power of 2 multiplied by resistor. So the value for inductor is 2.78 ampere. In order to find inductor maximum current, we have to put the value into the formula, as we can see in this slide. So the final value is 3.03 ampere. After that, we have to find the minimum value. In order to find this value, we have to put the value into the formula, as we can see. So the final value is 2.53 ampere.
And this is the application of the DC to DC booster. It's commonly used on automotive, power amplifier, adaptive control, battery power, consumer electronics, communication, and the advantage of the DC to DC booster, it gives the high output voltage, low operating duty cycles, and lower voltage on MOSFET, which means the switching the voltage when we use the voltage as the switching devices, it creates a lower voltage. Therefore, these are all is about DC to DC booster that I will discuss. So thank you for your attention, and that's all from me.
As the conclusion, we can now explain the significance using gate driver for converter circuit. After that, we also can understand the principal operation of boost DC-DC converter circuit in the figure. Last but not least, we are able to analyze the boost DC-DC converter performance on the variation of parameters. That's all for me. Thank you.